and I've got this fun little screen right here. We've got this binomial probability distribution information, and I'm just going to go through it with you guys really quick. Are you ready?
Mm-hmm.
Yep.
When you guys get to the exam, you can literally take this calculator and put in your own information. Okay. Have you guys used this tool yet to do the work?
Yes.
Yeah.
Okay. How are you guys feeling about all of the Excel formulas? I know I'm giving you guys a ton of them.
I feel pretty good about them. I was just wondering when it's because like for the different distributions, I guess there's different formulas for the mean and standard deviation. So I'm wondering if doing it in Excel is the same, or if that doesn't account for the different distribution that we're working in.
Gotcha.
Like binomial versus discrete or whatever it might be.
All right, so that's a really good question. And with the discrete distribution like this, it's different. Well, the standard deviation is essentially the same formula, but the way that you look at the way that you interpret it is slightly different. But you can still just highlight all of the data and just do standard deviation. So yeah, the standard deviation is the same formula no matter what distribution you're looking at.
Okay.
But how that standard deviation behaves is different inside the formula. The exception, let's see here. It's a little different with the uniform distribution, and the reason why is because a lot of times uniform distribution, you're not actually dealing with the real data. You don't have the real data in front of you. You say, okay, you've got this range, and everything is equally as likely to occur. Now let's calculate the standard deviation like we had all the data. And so that's why the standard deviation formula is a little bit different for uniform. Does that help?
Mm-hmm. Yes, that does.
Sorry,
I didn't mean to take you off topic.
Say what?
Sorry, I didn't mean to take you off topic.
Oh no, you're good. You're good. I want to ask questions because if you have questions, that means that you are ready to receive that information and apply it to exactly what it is that you're trying to do. So questions are, in my opinion, the best way to learn. But this right here is where a lot of people get stuck because they don't see how to. Ooh, do we got somebody else? Hold on. Nope, not yet. They don't see how to translate this to another example. Okay, so I'm going to give you guys another example. Are you ready?
Yeah.
Do you guys like Nerf guns?
Yes.
Sure. Okay. So I've got some Nerf guns. Let's see here. And I've got plans for this later. Well, I've got lots of Nerf guns. Let's do these Nerf guns right here. Okay. So this is not actually a Nerf gun. This right here is an Adventure Force gun. Now, do you know where to buy Adventure Force guns?
No.
Walmart. Walmart Adventure Force guns are normally actually better and more reliable than the actual Nerf guns. Odd fun fact there. And they're cheaper. Now, this is really important because how many of you guys have ever shot a Nerf gun and the Nerf gun jams? It doesn't shoot. It's something frustrating happens. And so you shoot like 50 bullets. You shoot like 50 Nerf darts. And when you shoot 50 Nerf darts, what's the probability of one of those Nerf darts jamming? What do you guys think?
I don't know.
Yeah, I don't know.
Low.
Well, you just have to guess. It doesn't have to be like a real answer.
Like 1 in 10, maybe.
1 in 10?
Yeah.
So about 10%?
Yeah.
Does that sound about right?
Yeah.
Okay. So people are getting frustrated. And if you actually look online, people are getting really frustrated with the quality of Nerf. And they're saying, hey, Nerf, you are not doing a good enough job with quality control. They jam too much. They don't shoot far enough. And Nerf is about to have a problem because other dart things they're coming up, and the companies they're coming up and they're saying, hey, you know what, we're better than Nerf, and Nerf is about to start to lose the battle. Did you guys like Nerf battle? Sorry. I'm really punny. So we've got these Nerf guns, and the problem is they jam way too much. So 1 out of 10 jams. So if I'm in the middle of a Nerf battle, and I want to know if I shoot a total of, I don't know, 200 darts, I want to know what is the most likely outcome. Okay, what is the most likely outcome of the number of darts that is going to jam if I shoot 200 darts? How would I go about figuring that out? Well, let's back this up for a second. The first thing is what is the empirical probability of success at each trial? What is a success? What is the success that we're dealing with?
It's not jamming.
Not necessarily.
That it is jamming?
That it is jamming. So you hear that word success and you think that it's a good thing, but success just means a positive outcome, right? It happened. So it jammed. So Megan, what's the probability of success at each trial that we said?
10%.
10%. So we're going to put 0.1 right here. So what is considered a success? So we're going to put this right here. Nerf dart jamming. Okay. Set number of trials. How many trials did we say we had?
50.
Sorry.
Did we say 200 or did we say 50?
Oh,
I
thought it was 50.
I might have said 50, and then I might have also said 200. Let's do 200 just because it's going to make life a little easier. So if you look over here, this is kind of cool. It has all 200 trials, the probability of all 200 trials right there. Okay, so the needed number of successes and the empirical probability of success at each trial. So what did I say the empirical probability of success was at each trial?
0.1.
0.1. And what does that mean, empirical probability of success? Empirical probability. It's a term.
I'm not sure.
Tom?
Yeah, I'm looking for the worksheet where it has the...
It was that really cool like video with the yellow background, and I was talking about the empirical probability of sports teams winning the Super Bowl as compared to classical probability.
Oh, yeah.
Y'all are like, I don't watch your videos. No, I'm just kidding.
No, I definitely do. I had to find it in all my notes.
Yeah.
The probability of an event happening as a fraction of the times similar events happening in the past. So just
exactly
to past events.
Okay, so in this situation, when I say empirical probability, when I say 0.1, what does empirical probability mean?
In the past, it's been 0.1.
Okay, in the past, it's been 0.1. In the past 10% of the times it jams. So in the future, we expect it to jam 10% of the time.
Okay.
Y'all tracking with me?
Yeah.
Okay. And so the first thing that we need to do is the mean or the expected outcome. So what is the expected outcome? How do we determine that?
You multiply the set number of trials by the empirical probability.
Okay. So we're going to do equals 0.1 multiplied by the number of trials. So the most likely outcome is 20. Okay. Now, what is the probability? Say, for instance, when I go into this Nerf gun battle, I want to have 15 or less jams. What do you guys think about that? Does that sound like a reasonable desire?
Yeah.
So the most likely outcome is 20. I want to have 15 or less. So if I want to have 15 or less, let's do this. What we're going to do here, somebody tell me what to do.
Need to do the function first, so equals and then the binom dot dist.
Binom dot dist. Okay.
And then I
So-
usually oh
Go ahead.
sorry. I was gonna
Go
say
right
I just click like X and then whatever value is like for X, I click that cell and then comma R in and then comma P and then false.
So if we want 15 or less, do we want false or true?
I think on this one you want true, right?
Right. So if we want 15 or less, we say true. I want cumulative. Cumulative means I want everything up to that. You guys tracking with me?
Mhm.
False means I want exactly 15. So I'm going to put false in there really quick. And that gives us the probability of exactly 15. I have a 5% chance of exactly 15 darts jamming. Okay. Or if I put true, this tells me I put fru. Don't put fru, put true. You probably can't even see it on your screen that I put a F instead of a T. It looks so similar, but that's 14% chance, right? So what that does here is it tells me the probability of all. So each one of these dots is an individual observation, right? So all the way up, this is 0.18, 0.16, 14. All of these points added up together, the probability of all these points added up together equals 14%. Now, that's not a horrible percent, is it?
No.
What do you guys think? Okay. And then there's also this right here with the range. And then if you wanted to do, like, for instance, binom dot inverse, let's do binom dot inverse equals binom dot inverse. Okay. And so this right here is if I want to be 95% confident, I want to say I want to be 95% confident that this many darts or less is going to jam. What do you guys think about that? What should I do?
Wouldn't you still put 0.1 there and then for R do 0.95, or would it be the whole number, like 95?
You know, it would be 0.95.
Okay.
And so you'll see right here, we go down to 27. And we are definitely 95% confident that 27 or less darts will jam.
Okay.
You guys tracking with that?
Mm-hmm.
Questions about this at all? No questions at all. Do you guys feel better about this now that we went through this with another problem?
Mm-hmm.
Yeah.
So I think for on one of the homework problems, if we're talking about like the coach smoky and like the 75 shots, I think for our X number in our the third row, I had put 40 at first, but all my numbers came out wrong like that. Why was it 39? You know what I'm talking about?
Okay, so the probability of making 39 shots or less. What is the probability of making 39 or less shots, which will keep them from winning? Okay, so you need 40 to win. Okay. So 39 or less means you lose.
Okay.
You tracking?
Yeah. I just needed it like explained. I don't know why it like wasn't making sense.
No, that's a great question. And to be honest, I'm gonna redo this entire thing. I just didn't have time. I've had a lot of complaints about this sheet. because let's be honest, I made it pretty daggone complicated, right? Um, it's very cumbersome, and so even though it's very thorough, I've got to work on finding a way to make it a little bit more streamlined. A lot of people get tripped up on this one, and so that's why I wanted to go over it with you and make sure that you guys saw it. Of hey, this is what we got to do. Okay, let's go over the uniform. You guys go with going over the uniform?
Okay. Yeah.
So the uniform probability distribution is the easiest of all the probability distributions. Okay. Okay. Did I do this one in the video?
Yeah.
This one right here? Okay, so I'm going to do this right here. I'm going to copy this, Control C. And I'm going to put this right here. Let's paste the values. Paste the values, and now I'm going to paste okay, just like this. So let's use an example. Did you guys ever go to Starbucks? Mm-hmm. You're like, we're college students, of course we do. Okay, so I have this I haven't gone to Starbucks as much lately, purely because I never leave my house because of COVID, but now I start to leave my house again. But I have this thing on my Starbucks app that anytime that it drops below $10, it automatically reloads $20. Okay. So I always have somewhere between 10 all the way up to $30. Okay. Now, if I have somewhere between $10 to $30, what we've got to do right here is we have to find the probability of any particular given outcome. How do we do that?
Don't you do 1 over the highest number minus the lowest?
Right. It's just 1 over the range, right? Mm-hmm. Okay, so it's equals 1 divided by 20 is the probability of any given outcome. Okay, so equals 1 divided by 20, because if you look at it, there's 20 individual dollar amounts. You split this up between 20 different dollar amounts. And so the probability of it being at $11 is exactly 0.5, right? You know, the probability of it being at, or when I say at $20, what I really mean is 20 up to $20.99, right? It's that $1 chunk. So imagine this being split up into 20 chunks. This is 20 chunks right here, and it's split up into 20 different chunks. Let's do 10, 11, and it's 29 up to 30, right? And so the probability of it being in any one of these individual chunks is 0.05. And then you just bring it all the way down, and then you add it all up, equals sum. And it'll add up to 1. Okay, how are you guys feeling about that?
Good.
Makes sense.
Okay, so if I want to know what is the probability of it being less than $20, we'll put 20 right here. Okay, all that we've got to do is take the range, 20 minus 10, multiply by 0.05. So being less than $20 or being between $10 to $20, multiply by 0.05, what do we get?
0.5.
Right, 50%. The probability of it being between $10 to $20 is 50%. So anytime that you want to know what's the probability of it falling within this particular range. So if I say, what's the probability of it falling between $27 to $30? What's the range?
3.
3 multiplied by 0.05.
0.15.
Right, 0.15. And so that's the probability of it being between $27 to $30. So just find the range, multiply it by this number right here. Over and over and over again. You guys feeling really good about uniform?
Yeah.
I mean, do you see how silly simple it is?
Uh-huh.
Yeah, once you break it down, it makes sense.
Yeah, I need to do a better job, like I said, once again, just breaking things down. My brain is very unique. I make things so daggone complicated when they don't need to be complicated. And then I go back through and I'm like, oh, let's just make it simple. All right, last thing. Have you guys even started on the standard normal distribution yet?
Mm-hmm.
You have?
I have.
Okay. So the standard normal distribution, the big key is with a normal distribution, you find what's that called? With a normal distribution, you can use these fun little formulas, or find the z-scores or find the probability of certain events occurring, so on and so forth. But the big thing that we're doing here is we are solving for this algebraic equation over and over and over and over again. And what we want is the z-score. Okay. And so it's these are the 4 elements that contribute to that: z, x, mu, and standard deviation. When you have these pieces of information, you can get the z-score. And once you get the z-score, you can either use the z-chart, or you can use this norm.s.dist to find the probability of it being higher or the probability of it being lower. And so the reason why I have this right here is because I want you guys to practice filling in all the missing values. And so like right here, as long as you have, these like 3 of these values, and you'll notice so there's a total of 116. Okay. So if we have right here 1.33, 96, and 85, all that we're doing is an algebraic equation, right? So we're going to solve for the standard deviation. So we are going to, let's see here, flip it. And so, fill in the information. And so if you flip this around a little bit, let's add insert. Let's move this around a little. And let me zoom in. So if we're solving for the standard deviation, what do I need to do to this? To this formula.
I'll just multiply it to the other side of the equation.
Right, multiply the standard deviation. So right now it's divided by the standard deviation. So now we're going to multiply both sides by the standard deviation. And now what do I need to do from here?
Divide by z-score.
Yeah.
Okay, so now we can solve to fill in this spot, right? Okay, and so let's see here. We are going to solve to fill in this spot. And so we're going to do equals x minus the mean divided by the z-score. which gives you 8.27. Okay. And so you guys see how it's just algebra over and over and over again?
Mm-hmm.
You're like, I hate algebra. I'm sorry. And then in order to find the probability, this formula right here, this norm.s.dist, gives you the probability of getting greater than this z-score. Okay, so we're going to do equals norm.s.dist, and then we're going to put the z-score. And then if we put cumulative, it tells us the probability of it being below this right here. And at least I'm pretty confident I tell you to put cumulative. Don't you all? It's so hard to keep all of these. I actually have a... Yeah, it's true. I have a cheat sheet that tells you what to do for all of them. Because sometimes it's just hard to remember. Do I put true? Do I put false? You know what I'm saying? Mm-hmm. But right here, cumulative, it tells you the probability of it being below this 1.33, and then equals 1 minus this tells you the probability of it being above this z-score. Okay. And last but not least, if we want to know what is the number that is lower, the number of observations that are lower than this z-score, all that we've got to do is take what is the probability of it being lower multiplied by 116, because there's 116 observations. So there's roughly 105.35 observations that are below this z-score. Okay. So I'm going to put another video out that goes through this as well, but I just wanted to show this to you guys and show you, hey, just solve for the solve for the algebra information right here, and then fill in the missing spots, and then define the number of observations that are lower. Just multiply it by the p-value of what's below it. Okay, questions, comments, inappropriate remarks? Okay, how are you guys feeling about all this information?
Better.
Definitely better.
Explained and everything.
Yeah.
So what I'd suggest you guys do is that you guys work through this as a group and compare your answers. Okay. This is going to help you a ton. This little cheat sheet. I really do my best to set this up so when you guys get into your exam, what I would suggest you do is go like this, and when you get to information, put in the information that you have and then solve for what you're missing. You guys tracking?
Yeah.
Yes.
And same thing here, you know, figure out what it is that you need to do and then go there. I really do my best to set these things up for you to set these things up for you to be able to use these on your exam. Same thing when you get to your exam, copy and paste the information that you have into here for the discrete. You know, use the same thing for the uniform, use this for the binomial, and then this doesn't help you at all with the normal, but